Okay, so another operation you can perform with functions is called a composite. This is when we use a function as the input of another. So the composition of a function g of x with f of x is written, h of x would be the new function equals g of f of x. So this you would say g of f. And so you use this little circle. Notice that that's not bubbled in, so that, because if it's bubbled in, then that means multiplying, okay? So this is g of f, or the gof. That's how, so that means that we're gonna insert f of x into the g. So now we have f of g of x. This is called the fog, okay? So that means that whenever this is inside, that means that's the function that's gonna go inside the f function. So that's gonna be, we're gonna replace that x with all of that. So that's x squared plus 6 plus 2. So that's gonna be x squared plus 8. So this is the fog right here. We can call it the f of g, okay? So then you're done with that one. The gof means this one, you're gonna put the f of x into the g. So you're going the other way. So I'm gonna erase this. So I'm gonna put all of this into that x squared. So that's gonna be quantity squared plus 6. Instead of having the x, I'm gonna put x plus 2. And then what I'm gonna do is FOIL this, x plus 2 times x plus 2 plus 6, so that's going to be x squared plus 2x plus 2x plus 4 plus 6. Combine like terms, so that's x squared plus 4x plus 10. Okay, so now we have the fog of 3. So that means that we got to put the 3 into the g first. So here's my g, that's 3 squared plus 6. So that's going to be 9 plus 6, which is 15. Now that 15 is going to go into my f function. So it's going to be f of 15 equals 15 plus 2, which is 17. Okay. So this one says f of 3. So we're going to plug the 3 into the f of x. So f of 3 is 3 plus 2. So we're plugging that 3 into that over here, which is 5. Then this 5 is going to go into the g, which is that. So g of 5 is going to be 5 squared plus 6, which is 25 plus 6, which is 31. Okay? So then that would be the answer there. Okay, so let's try these ones. F of 5, so that means I'm going to plug in the 5 in there. So f of 5 is 3 times 5 minus 8. So 3 times 5 is 15, minus 8 is 7. So now that 7 is going to go into the g. So I'm going to plug it in there. So g of 7 is going to be 2 times 7 squared, which is 2 times 49, which is 98. Okay. So g of 5, I have to calculate that one first. So that means that goes right there. G of 5, that's going to be 2 times 5 squared, 2 times 25, that's 50. And then you're going to plug that 50 into the f. So it's going to be f of 50 is going to be 3 times 50 minus 8. So 3 times 50 is 150. Take away 8 is 142. Okay. And then we want to find the g gof, the g of f. So that means I'm going to plug the f into the g. So this right here is going to go in there. So it's going to be 2 times 3x minus 8 quantity squared. So that's 2 times 3x minus 8 times 3x minus 8. So that's gonna be 2 times 9x squared. And then 3 times negative 8 is a negative 24x. Negative 24x plus 64. So that's 2 times 9x squared minus 48x plus 64. And then multiply by 2. So that's 18x squared, 18x squared minus 48 times 2 is 96x plus 64 times 2 is 128. So that would be your final answer. And tomorrow we will discuss the domain and range of composite functions. So that would be for tomorrow.